why don't we just pop the entire virtual machine down the network and somebody else can see it? And we do, and that's the way we're going to play around with it later on. It's had various names in the past, still called virtualization, which is the current buzz name for it. One of the earlier names for the same principle, or two principles getting together, is thin client. The concept of a remote machine accessing a host one. Let's roll back to earlier days. And consider at its simplest your RDP, Remote Desktop Protocol. Not uncommon with Windows, other machines will do it as well. In RDP, if you allow someone, they can access your machine. So at best, Granny's not well, and Granny gives you her passwords and where she is and so forth. You can log into Granny's machine remotely, change the settings, fix Granny's machine, Granny's good to go. That's RDP in Windows. There are similar sorts of things in other operating systems, generally using a protocol or service, shall we call VNC. And the VNC server is the one that has the thing you're going to share. The VNC server will be up there, and people with the client can see the VNC screen. We set up our VNC server software. We give people access to it. Danger, so be careful on doing that. Give people access to seeing your screen, seeing your files. The clients come in with VNC client software, and then they can see what you're doing and see your screen, help you out or whatever, or demonstrate stuff. VNC clients might run a different OS. So the VNC server might commonly be a Unix machine, Windows machine. Clients could be an Android or iPhone, something like this. They'll run the client. So you can see on your Android device, your iPhone device, your iPad or whatever, the screen of a full Windows Linux client or server or whatever. At its basic, there is no backwards. So at the moment, as I speak, there's no iPad VNC server, so I cannot by default see my iPad screen on a Windows machine. There are some unofficial devices for Android. You've got to root your Android device first, but we don't want to go there. So in theory, you could get it to your Android device on a Windows or Linux PC screen like this. That's the same plot up here with RDP and the VNC client software. Allow us to see the entire screen from somewhere else. At its simplest, it's screen scraping. So if you allow no access whatsoever, we take what's in our server machine and have a picture of the desktop with its icons or whatever, and the mouse. And as the mouse is moved, we just refresh that picture in the clients. So in fact, we're not actually changing the hard drive or moving anything virtually on the main machine. We just move the things around, and as this picture changes, these pictures change. And most of the information going back and forth is the changes in the picture, like a digital TV signal. If all I'm going to do is move my mouse around here somewhere, I'm only going to change that part of the picture, not the whole part. Which means it can be reasonably bandwidth tolerant. In other words, you don't need massive bandwidth to make this work. You do need some, of course. So that's one way we can play around. This is going towards virtualization because in fact, these are virtual machines. These clients are showing inside what they've got, this box. But they're not that box, they're somewhere else. With our RDP settings, we can also allow certain other things to occur, not just to see the screen, the mouse and so forth. We can also open files, save files, move things around if we allow permissions for that. So we're actually allowing commands to open disks, mount things, unmount or whatever on the remote server. So in that case, we've got here, the client might look like, we might have, for example, an Android client here, and then we have the big client desktop. We see Windows on here, but down the right bottom somewhere up here would be some standard Android icons, so we'd see Android stuff up here, and we'd see Windows up there. And we'd use Android to move around, because obviously your Windows window is pretty darn big, and your Android window is somewhat smaller, so we'd see part of that window and use the Android OS to move around mount it. That's our remote desktop solution. If we go the full thin client hog, then there's nothing on the client. Our full thin as you can get thin client has got nada in it, nothing. A basic, simple thin client box might be about that sort of size. It doesn't need a right lot of power, doesn't need a big efficient cooling system, doesn't need a hard drive. It needs definitely some sort of keyboard and mouse, probably needs some sort of USB input for storing stuff. It needs the best network connection you can afford to plug into it, and then we're away. Because all that does when it boots up is it boots, and rather than going, okay, I'm going to boot from my hard drive, USB stick, CD-ROM or whatever, it's going to boot from its network cable. That's PXE boot, PXE boot. So it'll boot from the network cable. Somewhere down the line in the network somewhere is the machine that's broadcasting itself saying, hey, if you want to boot through PXE, I'm here, I'm waiting, I am good to go. They have a quick chat in network protocols and agree that the client's allowed to have an image, bang it down straight down the line to the client. The client has then got a simple operating system, and depending on the exact setup, the exact routines, we can pull more or less stuff on the client. We can make our client less thin by moving stuff to it. An obvious one, certain programs and processors are heavy, meaning that you run more of them, the processor gets a bit strenuous or RAM, it slows down, it gets worse and worse and worse. For example, running Flash videos. Firefox had a bad rep some years back, but it's a lot better now. So if you ran them on the server and were sending this data back and forth down the wire all the time, a lot of traffic on the wire, and the thin clients were getting slower and slower and slower. You can, if you want, you make certain decisions. You could knock, say, Flash Player and Firefox down to the client and run it as a local app, which means that it's not got the weight on the server. So some stuff is running on the client and some stuff is running on the server. If we go back to our earlier story, whereby running from a CD-ROM drive. Your simplest live CD-ROM will not write to the hard disk. So it'll run up, read the CD-ROM, pop it into RAM and work on the RAM. Everything's stored in RAM. When you turn it off, you're done. We can do that with our thin client. Our thin client might have no hard disk whatsoever. Everything we've got is just talking back and forth inside the RAM of the thin client, and when we turn it off, it's forgotten. But we can send messages back to the server's fine, send it back to the server will remember, next time that client logs back on again, we can send the message back to the client. Or we can make the choice perhaps to put some of the data on the client and remember it on the client side. It's a choice we make. The more we put on the client, more data, more processing, the faster response we're going to get. But then again, we've got more programming worries and more need on the client system. Generally, the thinner it is, the more that runs on the server, the easier it will be to run. But the more hassle it will be if you're going to run an awful sort of stuff. No. With our typical thin client again, several schools run this. It's all you'd need is somewhere is your thin client server or servers, and they have the stuff installed in them. So you walk into a room, and then when you boot it, the machines boot from that room, and they appear where you are. So all the stuff is set on a single server. You come on your local machine, bam, you've got it. You might move to a different machine in a different room. It could be set to boot exactly the same stuff you had last time. So you might set up what you need for your accounts or whatever you do with your screen in room A. Save it all down. Come back next day in room G, and open in room G, boots the same client, same server, sees you, pops it down, and you're away like that, and you're back where you are. It can work better than that. We don't have to be local. We can pop all the data straight down the wire remotely. So, you could be at home, come into your remote machine, you see all your server program, all your standard programs on that, you're good to go, open it up, and you're away. So you haven't got to come into school or come into college, come into work. You can go from work or school or college, open up, and you're good to go, and all the stuff is there. Wonderful. Obviously, if you're at home, your bandwidth's not going to be the same as the bandwidth at work. So you're going to have some lag occasionally, possibly a lot of lag. Depends what bandwidth you've got. If you need an awful lot of stuff and you've not got the bandwidth, then it's not going to work. So if, for example, you're on a thin client system and you decide the thin client system to run YouTube programs on the server miles away, it's probably not a good plan. But understand the sort of stuff. So say you needed an office program, you needed something, we might install Sage, an accounting program. You might install that at our servers locally. You're at home, you can't get into work, you dial in, open your remote thin client session, bang, you've got access to Sage, you can do what you need and you're away. You're laughing. So it'll work handy like this. It's nice from the support person's point of view. We have at times run various out centres in places like Brighouse and Sarby Bridge and stuff like this. They come and go, sometimes they close, sometimes they open. We would normally need a server here, and locally in Sarby Bridge or Brighouse, there might be a separate server, and that would be having the local needs of logging on and accounts and stuff like this in Sarby Bridge or Brighouse. If they go wrong, our man has to, or lady has to get in his own car, drive down to Sarby Bridge, Brighouse or whatever, and go in there, open it up, do what they've got to do, and then drive back. Well, they could come in remotely from our centre, RDP perhaps, to the one in Brighouse and access them like this, which will work up to a point. But if they were also just in the same building anyway, walk downstairs, got full access to the hardware, do what you've got to do, fix it out like this, and you're laughing. So it'll work like this. It's a technology that's evolving. It might evolve into a beautiful, beautiful swan, where it might crash and burn ugly duckling-wise, but it's got a lot of potential and it's still moving forward. So there are issues on it. It won't always work. There are license issues. It's not a free gift. So if you're running a thin client Windows-based solution and you're offering people access to things like Word and Excel and so forth, you cannot just pop up your Windows server, turn him on, put it on your Windows server, put on your Excel, put on your Word, and allow every man jack to log in and you're good to go. Microsoft are not in the free business, well, some nice free stuff, but this particular bit, they expect you to buy a license for it. So you negotiate at the time how many thin clients can come in at a particular time to use it. So you might have a license to say that you can allow 100 thin clients to come in and allow your stuff at any one time when you'll pay for that particular package. And then if number 101 wants to come in, it's not going to happen. So it's nothing free like that. There are Linux versions that are free, or free down the way, run open source software, so you can run OpenOffice on Ubuntu or whatever you want, and it'll work like this. You'll see that there are things that can work like this. They're maybe not quite as neatly packaged, but they'll work fine. The host machine, the one that's pumping out those thin client images, is going to have to be multi-user. So usually these Windows machines, you log on as a user, dang, you're done, you've logged on, end of story. Somebody else then would have to log on separately. They don't have to, but it appears that way. You need a multi-user system, so many users log on to the same machine at the same time. I mean, at the moment you're logged on to these machines and doing whatever you have to do, but someone downstairs could be logged on by looking at what you're doing, make certain you're not playing some silly game somewhere or watching YouTube or whatever. So someone will come in remotely and watch what you're doing. The service needs to be multi-user as well. And Linux will work fine like this. So you'll log onto one machine and you don't know that you are on a remote machine somewhere, but it works okay.